Thank you. Good afternoon. It's a pleasure to be here and to share some of the work that we're doing at Technische Universität Berlin. And in my team, we started basically looking into blockchain technology about early 2016, and since then have built a number of systems. And out of these systems, obviously, we like to learn how to design other applications with a particular focus on different qualities. So we're looking at blockchain technology mostly from a distributed systems perspective. So I'm a computer scientist, also by heart, but I'm not a crypto or security person. I'm much more a distributed systems, database management, or software systems engineer. And so much of what we're looking at is then to support and enable different kinds of qualities for such systems. So privacy obviously is one of them. Closely related to privacy in many blockchain discussions is scalability. And then there's many more others that we're going to look at. I'd like to share with you some of the work we have done, particularly in the context of off-chaining, and one particular solutions, even in off-chaining, then is Zokrates, a system that has been primarily designed and built by one of my PhD students, Jakob Eberhard. So one of the applications we're currently working at in our university is a project funded by the Federal Ministry for Economic Affairs and Energy. And this is a future energy network. And so during Decentralized so far, we heard a lot about finance. And obviously, finance is one of the main starting areas and application domains for blockchains. But then energy is quite huge. In fact, we're looking at a almost increasingly large number of different energy-based energy projects that use blockchain technology. And so we started this project earlier this year, and will run for 2 more years, where we're looking at photovoltaic energy systems that are by nature decentralized, independent of blockchain. Where then the photovoltaic producers and consumers, so the prosumers, will be able to share and trade energy on a peer-to-peer basis. This is nothing new. You may recall systems like the Brooklyn microgrid several years ago, and by now there's countless more systems out there. I'll come back to this application a bit later when we start looking at fresher or current requirements regarding all types of qualities, again, from scalability to reliability and so forth. This is not necessarily about 20 households being interconnected, but we're aiming at larger numbers. Also, we are equipping in this project the individual households, large or small, with actually energy storage capacity. So this is allowing us to run completely different market issues. The moment you see this, obviously, energy networks are decentralized by nature. Blockchain seems to be a natural candidate to support systems like that. Privacy issues emerge immediately. How much of an individual transaction should actually be transparent to everybody on the network? And for the blockchain, obviously, transaction transparency and everything is one of the desired goals. But at many times, privacy is about you as an individual having the right to and the say basically over what should be shared with us and what not. Once it is in the blockchain, it is there. So it's, if you can call it also sometimes garbage in, garbage out, with the difference that whatever goes in is agreed, but we should be careful in what has to go in there and what should not be going into the blockchain. So, and obviously it all started with Bitcoin back in 2008, and since then one could say 2 major dimensions and directions that we have seen quite some efforts in are either related towards generality, and not even related to privacy. And solutions like Zcash obviously do quite a nice job for Bitcoin-based systems. And on the other hand, we have the evolution towards Ethereum, which is a much more sophisticated, from my point of view, and much more powerful blockchain technology. And obviously the question then is, what about privacy in an Ethereum context? This is really a much more difficult question, since we're aiming at a solution that must cater for broader issues. This is the thesis. The thesis, and there's no formal proof for this, but the thesis really is that preserving privacy in public blockchain probably cannot do without off-chaining, right? So and I'll tell you a bit on what this means. Off-chaining, from the way we like to look and define this, is just a very brief definition, is about using anything external to the blockchain. Not just one particular other technology, not just one particular other file storage system, another network, and so forth, but an arbitrary set of technologies that are external to the blockchain that you're using. But the way you use this technology, this external resource, must be in a way that you do not compromise any properties of the blockchain. Otherwise, there's no reason to use and introduce blockchains in the first place. So if you're aiming at full transparency, at transaction immutability, at agreed consensus-based storage of data that is identical at every peer, and so forth, all these good properties about blockchains, obviously you cannot violate these and should not compromise these by now adding suddenly or integrating a customer database that would sit outside the blockchain. So whenever some external resource, some other technology is being used, we must not compromise the blockchain properties originally intended. So one of the early systems we built, we started in 2016 by implementing online chess. And online chess is not about changing the entire gaming industry, but it was a very good exercise, in fact, to learn about some of the issues. And if you think about implementing online chess, the immediate question is, so what would actually go on the chain? And what should probably not go on the chain? Would you record every move that a two-player game does on the blockchain, regarding all the expenses and different system qualities resulting from it? Or would you do it differently? And so out of this system and a number of other POCs have followed, some in direct collaboration with industry, some in larger consortia projects, we have identified an initial set of patterns. For example, the challenge-response pattern in this chess context, we also refers to the fact that computing endgame conditions in chess is far too expensive to be done on-chain. With public blockchain, you would have the requirement that every peer would, every node in the network would have to do so. So we better not do this, but we do the computation at the client side. And we instead model smart contracts that implement state transitions, because transitions are easy to compute and cheap to compute, and then use a challenge model to question any potential straight transition. And so there's an initial set of these off-chaining patterns that look at various ways on how to do things outside the blockchain while still maintaining and not, again, compromising any blockchain properties. One of these patterns is also what we call delegated computation. And again, if you look to the left, you see what on-chain processing in the public network is typically about. Every peer in the network validates and processes every transaction. It's quite costly, highly expensive, particularly from a distributed systems perspective. To the right, the idea is that we do the expensive computation somewhere outside the blockchain. Here, for example, with a prover. And instead, we remain, however, on-chain proofs for verification purposes. Again, this is for reasons to ensure and not compromise any blockchain properties. So, for example, if you claim that you have knowledge of the pre-image of a given hash, then ideally, and before coming to decentralized, in fact, I wasn't sure how technical this conference will be. I'll be short about this, or I'm almost skipping this. But ideally, you'd like to express something like this in a higher level language that looks like this. You'd like a higher level programming language to program such executions, have them off-chain executed and only verified on-chain. Right? And hide all the difficult math that exists behind zero-knowledge proofs and everything that are at the current state of blockchain technology really subject only to very few experts. You have to be quite skilled actually to program and understand all the math behind ZK SNARKs and so forth. So we started with the Zokrates project, and we've been lucky to have support from Ethereum from day one for the Zokrates project. And what the Zokrates project is really about, that we do have this higher level programming language now that allows you to program such off-chain computations. And then we have a compiler which translates these programs into, on the one hand, a prover that resides on the client and will be then executed on the client side, and a smart contract, which is then, of course, executed on the blockchain network, along with an entire pipeline of tools for setup, for witness computation, proof generation, and so forth. This makes zero-knowledge proofs suddenly programmable and accessible to a much broader audience other than very few skilled experts. The Commandline Interface, and I'll be also brief with this, is essentially, again, you're starting from the code. We have a number of tools that transform this into other representations where we then can use, again, different existing libraries to then have both a prover and a verification key, which is then directly included in the smart contract and supported with the current Ethereum. So for this vision of that we have generality versus privacy as on the two axes of where blockchain technology can develop, we're suggesting Zokrates as a tool. And of course, it's all open source, accessible. There's an increasing community base contributing also to the code and working with this. Ethereum itself is sponsoring a number of developers contributing to Zokrates. And obviously, I would like to invite you to have a look as well and to engage with us in discussions and potential applications. Beyond privacy is things like GDPR. So I missed the earlier session today on GDPR. But again, if you look at this energy scenario, GDPR, and this is just taken from Article 5, is way more than, let's say, aspects of confidentiality or data minimization. And most of the security research we're seeing today in the privacy space is actually about confidentiality and data minimization. But if you look at what GDPR demands, and there's quite a lot. Lawfulness, fairness, transparency, purpose limitation, even storage limitation for that matter, and so forth. And this goes way beyond just selecting a set of security technologies and security mechanisms which would be ready to apply and to be used in the context of such future energy systems. This requires taking us a much broader look, again, beyond crypto, beyond security research, combining different disciplines from within computer science and as well as outside computer science. This is something that we are, of course, highly interested in, and this is where, from the technology side, we're getting closer to open research questions. This is also already my summary. At TU Berlin, we are engaging a number of application systems. We're looking at future energy systems. We're looking at future logistics scenarios. We're working with German car manufacturers, OEMs, regarding future autonomic driving scenarios and mobility systems. And in all of these, we're interested, of course, in the decentralized networks that we envision for the future to be actually employed and built and deployed in a real-world context. On the one hand, we believe that systems and solutions like Zokrates can play a critical role in introducing or enabling privacy to an extent that currently is not doable, that otherwise is not doable. And on the other hand, we have a number of open issues related to GDPR where we're still seeking for the solution and where we'd be very happy to engage with you also in future collaboration. And with that, I'd like to thank you for your attention and happy to take a few questions. Any questions?
Guten Tag.
Guten Tag.
Are you guys working a little bit with the IOTA Foundation in terms of that sort of thing as well?
No.
No? Okay.
To be honest, probably from day one, we've been focusing mostly on Ethereum. And of course, we've been playing a bit with permissioned blockchains as well. But primarily, we believe that from the programming model, from everything that we see, Ethereum is fascinating enough to spend a lot of time at.
Yeah, definitely. But I find IOTA interesting because they solved what Satoshi solved in terms of the double spend problem, but in a different way. And in having Fearless, I know they're working with VW and Bosch and things like that at the moment. Similar to what you guys are researching.
Right. Probably it's worthwhile to take a look again from when I recall that my team and myself, we looked into IOTA. We couldn't get it running. And again, we're a team, we like to build systems. We like to actually build prototypes and see it live and running. And we haven't really seen that from many of the blockchain technologies out there. Even to come back for the energy use case, again, you've seen Brooklyn Microgrid started with 5 households, Ledger in Australia or many others. It's like 20, 30 households, that's about it. Many blockchain prototypes are 3 nodes deployed on a single machine. And if we look, we're currently doing a survey also related to energy networks that are blockchain-based, that claim to be blockchain-based. Either these are ranging from white papers and ICOs to large companies to researchers. We have counted over 200 initiatives and projects. But when actually looking into, have they built a system? Is it in use? Can we ask questions at how many transactions per day? Or if they claim to be an auction, how many auctions do they actually run? Is the system in use? Then it's surprisingly weak in what you can find or what you get as information. And it appears that much of this remains on a conceptual and white paper base. So happy to see if IOTA is at a different stage now, and then it's definitely worthwhile for us to take a look at that again.
They're based in Berlin.
Yeah, everybody's based in Berlin, like you also. Yeah. Any other questions?
Hello, thank you for the presentation. It was really interesting. I had a question. The first one is some question. So the first one is Zokrates a second layer on top of Ethereum, or you did a hard fork? Had a fork on Ethereum, like really changing in the core Ethereum code?
Neither. We're not changing Ethereum at all. Again, the idea is that it's only a way on how you build your blockchain network. And we're saying that, of course, you're using a technology like Ethereum or any other blockchain technology as you like it, but still, the technology doesn't tell you on how to write a smart contract or what should go into a smart contract or what data or what transaction data should actually be on the network, neither the data nor the code. So for that's what engineering practice is about. And what we're saying is that maybe for very expensive computations, and whenever the computation is more expensive than the verification of the result of the computation, then do the computation elsewhere, anywhere you like, on the cloud, whatever, on a system that you have. Pick a hybrid architecture that you want. In order to relieve the responsibilities from the individual peers in the blockchain network to do that expensive computation, but still ensure that you have means to verify regarding all critical properties of the blockchain that it is a blockchain conformant computation, so to say. So maintaining this agreed consensus, verifiable at every node and so forth. So this is what Zokrates is really about. And we're employing ZK Snark, so it's not something we invented, but we're making this, hopefully at least that's our one of the main objectives, we make it accessible and programmable to a wider audience.
Okay, so does it mean that you have an architecture that could be applied in different blockchains that has the same, like the same architecture than Ethereum, like? Ethereum-like.
Conceptually, yes, but it's still not trivial to do so. And even in the process, and I briefly showed this overview of this Commandline Interfaces chain, in the end, there's a number of different libraries and a lot of specific code involved. So it's not a trivial thing to do this for another blockchain technology. And again, probably every other blockchain technology would come with different sets of requirements. And again, if we would start to look at IOTA, probably the off-chaining solutions definitely will look different. But in the context of public blockchains with a focus on Ethereum, this has been much focused to Ethereum and the smart contract model as it exists in Ethereum.
Thank you.
Let's have our last question. Maria, let's have our last question.
So hello, it's actually two questions. One is, you offload most of the crypto computation outside the blockchain because anyway, if you do it in Ethereum, it's going to consume too much gas. So my first question is, if I wanted to use Zokrates with a different blockchain, how difficult would it be to do the port? So how closely knit is into Ethereum? So this is one question. And the second is that usually when we use applications that have to do with zero knowledge, we also need an implementation in the front end, which may run in the browser. So we need to have compatible crypto in JavaScript. So do the ZK snarks that you use have compatible implementations of the underlying curves, for example, in JavaScript?
So I think your first question is very close to the previous question, unless if again, we have not looked into what an equivalent Zokrates system would look like for other blockchain technologies. Conceptually, I think there will be much similarity, but from scratch, I would say there's a huge line of exploring and research ahead of us to actually then come up to a solution that works. There's still a lot of work to do remaining also in the Zokrates system. Now, Zokrates comes itself with a higher level programming language. That language is meant to be used to program those off-chain computations. It's not always saying that you're using JavaScript or anything else. We need that language because only that language we can ensure that it's mapped correctly to the different other constraint representations that we need to then exploit standard ZK Snarks libraries and tools. Not sure if that answers your question, but otherwise we can also take this offline afterwards.
Right. Thank you very much, Professor.
Okay. Thank you.